Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, today we're going to learn how to balance chemical equations. Why do we need to balance chemical equations? Well, because we have a law of conservation of mass, and that law states that matter cannot be created or destroyed, and that means that atoms cannot be created or destroyed. And if atoms cannot be created or destroyed, the same type and number of atoms before the reaction has to equal the same type and number of atoms after a reaction. So let's go. Let's go to my screen and balance some chemical equations. Here is everything I said, and let's go and balance it. So right here, we're going to learn how to balance hydrogen and oxygen are combining to form water. Okay, let's have to quickly erase this. Okay, here we go. Hydrogen is a diatomic molecule, and oxygen is a diatomic molecule. We have to break apart some bonds, we have to rearrange atoms, and we have to create new bonds, new molecules. Okay, we have to make water. Water formula for water is H2O, so that means we have one oxygen. We will have to move one oxygen here. And then we're going to move one hydrogen to make water right here. And then we're going to move that other hydrogen. So I used one hydrogen molecule, but I only used half of oxygen molecule. So let's do, I cannot have just oxygen atom. So let's make one more water. I'm going to move this oxygen here. I'm going to move this hydrogen over. And I'm going to move this hydrogen over. Here we go. So what did I have? What did I do? I used two hydrogen molecules. I used one oxygen molecule, and I made two molecules of water. Let's count our atoms to make sure. I used up 4 hydrogen atoms. I used 2 oxygen atoms. And after my reaction, I still have 4 hydrogen atoms and 2 oxygen atoms. Okay. When balancing chemical equations, I like to teach a Tarzan method. It's a great method. So you remember Tarzan. Hopefully you heard of Tarzan or you watched a Disney movie. What does Tarzan do? Tarzan grabs onto a vine and then he swings along from tree to tree, holding onto that vine. And that's what we are going to do. So the Tarzan method goes like this. You're going to start with a 1 as a coefficient of a most complicated substance. You are going to decide what's the most complicated substance to you. If you really don't know where to start, just put 1 in front of something. That's a start. You're going to work on one element at a time. And then you're going to grab onto that element and you're going to swing to the other side of an arrow. You're going to swing from your reactants to products or from products to reactants. And that's what I mean by Tarzan method. You're going to save hydrogen and oxygen for last, especially in combustion reactions. Why? Because they seem to be all over, usually used all over in your compounds. So leave it for last. The last step, if you realize you have an odd-even situation, you don't panic. You take a deep breath, and then you double the coefficients that you have. And then you try again. Chances are it will work out at this time. Okay, let's balance some chemical equations. Let's go to the first one. Let's look our, everything before the arrow is our reactants. Here is our reactants. And everything after the arrow is our products. Okay, let's balance it. We're going to put 1 in front of the most complicated substance that you think. And I'm looking at it, and I think the first one looks most complicated. It has 2 different elements, and it has the most amount. So I'm going to put 1 in front of here. I'm going to grab onto boron, and I'm going to swing after my arrow. So 1 boron before the arrow, I'm going to have 1 boron after the arrow. Okay. Now that I have BP, I'm going to grab onto phosphorus. I have 1 phosphorus before the arrow. Let's go to 1 phosphorus as my products. Let's go to phosphorus as my reactants, and I have 4 of them. Okay, I need to put 1 here, and now I need to swing back. I have 4 phosphorus atoms as my reactants. I need to have 4 phosphorus as my products. And now also, I have 4 borons. I need to go back, and I need to have 4 borons. Here we go. And now, when we have BCl3, let's grab onto chlorine. I have 3 chlorines per molecule, 4 molecules, 12 chlorines. Let's go all the way to my products. I'm going to have 12 chlorines. And now I just have to do hydrogens. 12 hydrogens, I need 12 hydrogens. My reactants hydrogen is diatomic, so I need to have 6 right here. And you can double check, and my reaction is balanced. Let's go to the next one. I think you agree with me that the first compound is the most complicated one. So let's put a 1 in front of it. And I'm also looking at this, and I see that oxygen is in 3 compounds here. So do not touch oxygen. It will be really hard. Start with something simple. Let's start with nitrogen. I have 2 nitrogens, and you say, why do I have 2? Well, I have 1 nitrogen here, but there's 2 after the parentheses. So I have 2 nitrogens. So let's keep going. So 2 nitrogens as my reactants. I have now 2 nitrogens as my products. Let's put 1 here. Let's go back. I can use hydrogen here, no problem, because I have hydrogen in only 1 compound before the arrow and 1 compound after. So let's use hydrogen. I have 8 hydrogens before the arrow as my reactants. Let's go to hydrogens after. I need 8. I have here times 2, so I need 4. So here is now 8 hydrogens. Now let's check my chromium. I have 2 chromiums, and it seems like oxygen will be my double check. So I have 7 oxygens as my reactants. I have already 4 oxygens here. Here is 3. I need just 1. I need 1 oxygen right here. Okay, let's go to the next one. I have pretty complicated substances, but you can quickly glance and you can see that in this case, hydrogen is in 3 compounds of this chemical reaction. Do not touch hydrogen. Leave hydrogen for last. So let's start with zinc. Let's put 1 in front of this substance. I have 3 zincs. Let's go to after the arrow. I need 3 zincs. Let's put 3 here. 3 zincs. Let's go back to before the arrow. I have 2 antimonies. SB is antimony. 2 antimonies. Let's go after the arrow. Let's keep going. And I'm going to put 2 right here. 2 antimony. Okay. I'm going to go to my zinc hydroxide, the substance that has 3 in front of it as my coefficient. And I'm going to grab onto oxygen. So I have 2 oxygens, I have 2 hydroxides times 3 of them, so I have 6 oxygens. I'm going to go, I need 6 right here. Here is my 6 oxygens. And now I can double check with hydrogens to make sure it all adds up. So I have 12 hydrogens as my reactants before the arrow, 12 hydrogens. And after the arrow, I have, well, let's look here. Here is 6 hydrogens in my first, 2 hydrogens in the first compound times 3, there's 6. And then there's 3 times 2, also 6, so 12 hydrogens after. And it all balances out. Okay, you ready for last one? Last one, let's go. I need to put 1 in front of a most complicated substance, and I'm quickly looking at this, and I see there is oxygen all over. Every compound has oxygen. Do not touch this. I'm going to use oxygen as my something to double check if I balance the reaction. I need to put 1 in front of some compound. So compound 1, the first compound, let's go here. This compound has 3 different types of atoms, and this compound has 3 different types of atoms. So I have to put 1 in front of something, so I'm going to put 1 in front of phosphoric acid. I'm going to put right here 1 in front of it. Okay, I'm going to grab onto phosphorus. I have 1 phosphorus. I want to go to my reactant side. Oh, I have 4 phosphorus. Okay, so this will become 1. Let's go back, change this to 4. Okay, so I have 4 phosphorus and 4 phosphorus before and after the arrow. Let's grab onto hydrogen. Hydrogen is okay to do because it's only 1 substance before the arrow and 1 substance after the arrow. So I have 12 hydrogens total after the arrow. Let's go to before. I will need 12 hydrogens right here. 12 hydrogens, okay. Now, let's grab onto chlorines. I have 12 chlorine before the arrow, so I will need 12, but it's Cl2, so I will need 6 here to make it 12. Okay, let's double check. Let's use oxygen to double check. So I have 4 times 12, 4 times 12 plus 10, and that will give me 58 oxygens. And right here, I'm going to have 4 times 4, so 16. And I'm going to have 6 times 7. And that will actually give me also 58 if you quickly do the math. So I used oxygen as something to double check. And that is it. So use the Tarzan method. Swing from one side of an arrow to the other side. From reactants to products, products to reactants. And that's how you balance chemical equations. Thanks for watching.